السلام عليكم ورحمة الله وبركاته. أهلا بكم أعزائي الطلاب. اليوم إن شاء الله في هذه المراجعة سوف نتحدث عن الدرس الثالث المذكور عندنا في الكتاب وفي أسئلة الهيكل. راح نغطي جميع الأفكار التي وردت في أسئلة الهيكل من هذا الدرس. الآن في هذه المراجعة إحنا راح نغطي فعليا عدة أجزاء، وراح نبدأ إن شاء الله الآن في الجزء الثامن والجزء التاسع من أسئلة الهيكل اللي هم calculate the speed of electromagnetic waves in different mediums of different dielectric constants and apply the wave equations or equation to calculate the wavelength, frequency or speed of electromagnetic waves. الآن في بداية الأمر راح نبدأ بتعريف electromagnetic waves. Electromagnetic waves basically are waves created due to vibrations between electric and magnetic fields that can propagate in vacuum and manner. The direction of oscillation of the magnetic field is perpendicular to that of the electric field. المقصود بذلك if you look at this image, we will see the two different types of vibrations that we have in electromagnetic waves, which is basically a combination between the electric field and the magnetic field. Electric field باللون الأحمر والmagnetic field باللون الأزرق. If we assume that the electric field is oscillating in this axis, and let's say that this is the y-axis for instance, and let's assume that this is the x-axis or z-axis, we can call this the z-axis, that you can see that the electric field is oscillating in the y-axis, and B, the magnetic field is oscillating perpendicularly to the y-axis and the z-axis. طيب, what about the direction of the propagation? حكينا الآن the propagation direction for both waves is perpendicular to both. يعني both waves will basically propagate in the x-axis, which is perpendicular to z and y-axis. هاي معلومة مهمة. الآن ننتقل لبعض ال common characteristics of electromagnetic waves. أولاً, we should know that they can propagate in vacuum. For instance, عندنا طبعاً أهم مثال على ذلك اللي هو ال waves that are coming from the sun. We know that the light, for example, that is coming from the sun can go through the space to the earth. يعني basically we receive the sunlight despite the fact that we do not have any kind of matters in the space. لأنه احنا بنعرف بأنه السبيس عبارة عن شو؟ عبارة عن فراغ. ولما نحكي كلمة فاكيوم ما المقصود فيها في الفراغ؟ يعني لا يوجد عندنا أي نوع من أنواع المادة، لا يوجد هواء، لا يوجد ماء، لا يوجد أي مادة صلبة ممكن الويفز أنها تنتقل من خلالها. لكن that does not mean that they cannot propagate through mediums. They can propagate in any type of material, in any medium. لكن they are the fastest in vacuum. طيب, كم بتكون سرعة الآن عندنا electromagnetic waves في الفاكيوم؟ They have the speed that we call the speed of light. The speed of light in vacuum. How much is it? It's 3 times 10 to the power 8. And we usually use the letter C or symbol C to represent the speed of light in vacuum, which is the maximum value it can get. الآن النقطة الرابعة, they can transfer energy from one place into another. طبعا احنا بنعرف أو بإمكاننا الآن احنا نحس بحرارة الشمس, فبالتالي we understand that electromagnetic waves can basically transfer the energy from the sun to the earth without the need of any kind of mediums. Finally, they can be reflected and refracted. طبعا we also have different types of characteristics that we should know of. First of all, we should know what is the wavelength. The wavelength is the distance between the crest to the crest. This is called the crest, اللي هي القمة. طيب, or it's the distance between the troughs, يعني the distance between this point and this point. تمام, المسافة بيناتهم راح تكون عبارة عن ايش؟ عبارة عن التروف. عفوا, المسافة بيناتهم راح تكون wavelength, and these are called the troughs أو القيعان. So the distance between them is also called the wavelength. We use the symbol lambda, this is called lambda, to represent the wavelength. And the unit of measurement of wavelength is meters. إذا وحدة قياس الwavelength أو طول الموج اللي هو بالمتر. We also should know what is the meaning of an amplitude, لكن مش مطلوب منا فعليا, ما راح نشوفها في هذا الجزء. Amplitude is the distance between the equilibrium position and the crest, or the distance between the equilibrium position and the trough. This vertical distance is called the amplitude. Right. We should also know what is the meaning of frequency. Frequency is basically how many oscillations we have, the number of oscillations or vibrations, or oscillations, the same thing, per second. How many complete oscillations we have in 1 second. And there is also something called the time period. Time period. A time period is the reciprocal of the frequency. It's 1 over f is equal to T capital. T capital is the time period. And what is the time period? T capital, a time period, is the time needed in seconds to complete one full vibration. One vibration. طيب. نيجي لهذا الكلام بالتفصيل. أولاً, the wavelength is the distance between the two successive crests or two successive troughs of the same field. الآن, frequency, it is the number of complete oscillations performed in 1 second, and speed, electromagnetic waves travel at a constant speed in the medium, where this speed differs from one medium to another. And this is extremely important. We should know that as the electromagnetic waves move, or let's say they travel from one medium to another, the frequency and the wavelength does not change. The only thing that changes is the speed of the electromagnetic waves. Yani, for example, if we have, let's assume that here we have water, and this is air. As the light waves, they transfer or they travel from from air to water, basically their speed will either increase or decrease. And we should know that it's the fastest in vacuum than air. فبالتالي, as we go to water, the speed of the electromagnetic waves will go down. فبالتالي, as they move here, they will have a different speed. But the frequency will remain the same. The frequency will remain the same. So here their speed would go down, and the speed of the electromagnetic waves in air would be greater than it is in water. طيب, لأن هذا القانون جدا جدا مهم، ورد عليه عدة أسئلة في الهيكل، وإن شاء الله راح يجي عليه السؤال بشكل مباشر. أهم شيء لازم نعرف في هذا القانون إنه وحدات القياس لازم نلتزم فيها. يعني الويف لينث is measured in meters. V السبيد is measured in meters per second. والفريكونسي it's measured in hertz. طيب, نأخذ مع بعض السؤال الأول اللي هو فعليا الرقم 74 استكمالا للجزء الأول والثاني. في هذا السؤال بيحكي لنا electromagnetic waves travel through a vacuum at the speed of. We should know that they travel at the speed of light as they travel through vacuum. So the answer is B. ننتقل إلى question 75. Which of the following statements is true about electromagnetic waves? A. They require a medium to travel through. That is incorrect. B. Their speed varies depending on their frequency. That is also incorrect. C. They can travel through the vacuum of the space. This is correct. D. Their speed does not change as they move through different mediums. That is also incorrect because they require no medium to travel through. Their speed actually does not depend on the frequency. Regardless of the frequency or the frequencies of the electromagnetic waves, we should know that different types of electromagnetic waves have different types of frequencies. Regardless of that, they have the same speed in the medium. يعني, if we have, for example, radio waves and gamma rays, if they both are traveling in the space, both will have the same speed of light اللي هو 3 times 10 to the power 8. لكن if they travel, for example, in air, the speed will go down. What about, let's say, for example, water? This also means that the speed will also go down. فبالتالي لازم نعرف بأنه regardless of the frequency, يعني regardless of the type of the electromagnetic wave, they all have the same speed in the same medium. طيب, إذا بناء على ذلك, they can travel through the vacuum of the space is the true one. طيب, ننتقل الآن إلى question 76 اللي هو عبارة عن question 38, 39 and 40 in the book. نبدأ مع بعض في السؤال الأول. هذا السؤال بيحكي لنا what is the wavelength of green light that has a frequency of 5.7 times 10 to the power 14 Hz. فعليا هو معطيني الفريكونسي. نبدأ دائما بكتابة القانون لامدا equals V over F. So here we want to find the wavelength lambda. The speed is not mentioned. So in this case, if the speed is not mentioned then we will assume that this is the green light that is moving in space, meaning that it will have the speed of light in vacuum. So instead of writing V, we will write C. And we know that C has the value of 3 times 10 to the power 8, divided by the frequency that is given in the question, which is 5.7 times 10 to the power 14. طبعا using the calculator now, we can find the answer. Then 3 times 10 to the power 8 على 5.7 times 5.7 times 10 to the power 14. Here the answer is around 5.26 times 10 to the power negative 7. Then 5.26. Let me double check. There is something incorrect. Yes, this is correct. Correct. 5.26 times 10 to the power negative 7. 5.26 times 10 to the power negative 7. Again, the unit of measurement of the wavelength is meters. Let's go to question 39. An electromagnetic wave has a frequency of 8.2 times 10 to the power 14. What is the wavelength of the wave? Again, we will solve it in the same way. The speed is not mentioned, so we will assume that it's moving with the speed of light in vacuum. In that case, lambda will equal to the speed of light, which is 3 times 10 to the power 8, divided by the frequency given in the question, which is 8.2 times 10 to the power 14. Now, going back to the calculator, I think we can just change the denominator to 8.2. And the answer will be around 3.66 times 10 to the power negative 7. Then 3.66. And the unit of measurement is meters. Finally, what is the frequency of an electromagnetic wave that has a wavelength of 2.2 times 10 to the power negative 2 meters. الآن أعطاني الويفلينث، يعني أعطاني اللامدا، وطالب منا نحسب الفريكونسي. Again, the speed is not given, so we will assume that it's moving with the speed of light in vacuum, meaning that we can write down the equation lambda equals C over F. نعوض مقدار الآن الويفلينث is given as 2.2 times 10 to the power negative 2 equals 3 times 10 to the power 8 divided by, and again we can use the calculator to find the frequency. We will write down 2.2 times 10 to the power negative 2 equals 3 times 10 to the power 8 divided by the frequency, which is the unknown value, keep it x. Now do shift, so بطلع لنا الجواب 1.36 times 10 to the power 10. Then F is equal to 1.36 times 10 to the power, I think negative 10. Yes, or 10 عفوا. So this is 10. And the unit of frequency is hertz. And that is it for questions 38, 39 and 40 from the book. ننتقل الآن إلى السؤال رقم 77. Question 77. A wave makes 3,000 vibrations in 0.2 seconds. What is the wavelength of this wave? طبعا لما يحكي لي الآن in 0.2 seconds يعني المقصود فيها طبعا إيش؟ اللي هي 0.2 seconds basically. لما يطلب منا الآن wavelength ما أعطانا speed, specific speed, so we will use the speed of light in vacuum. أولا كيف إحنا راح نطلع مقدار for example الفريكونسي؟ We should know that frequency is equal to the number of vibrations divided by the given time. الآن given time هو عبارة عن إيش؟ 0.2 seconds، أو خلينا نكتبها time generally speaking. الآن راح نقسم الرقم اللي هو 3000 على ال given time اللي هو 0.2 and use the calculator again. 3000 divided by 0.2 بيطلع لنا الجواب 15,000 and the unit again is hertz. Then from there we can use lambda. Lambda equals the speed of light c over f. نعوض. الآن we want to find the wavelength, so lambda is unknown. c is equal to 3 times 10 to the power 8 divided by the frequency, which is 15,000. Now using the calculator we say 3 times 10 to the power 8 divided by 15,000. يطلع لنا الجواب around 20,000. So again the unit for lambda, so this is 20,000 and the unit is in meters. هيك احنا بنكون خلصنا هذا السؤال بشكل كامل. طيب ننتقل الآن إلى الجزئية اللي بعدها اللي هو موضوع electromagnetic spectrum، نتكلم عنها شوي قبل ما ننتقل للسؤال العاشر. Electromagnetic spectrum is basically the range of different wavelengths and frequencies over which electromagnetic waves extend. Now this has to be memorized. هو عبارة عن شو؟ عبارة عن electromagnetic spectrum. We start from the gamma ray, then go to the X-ray, to the ultraviolet, visible light, infrared, microwaves, and radio waves. Or you can go from radio waves, then microwaves, then infrared, then visible light, then ultraviolet, then X-ray, then gamma ray. So we can either go from left to right or from right to left. طيب, what should I remember? You should remember that as we go from radio waves to the gamma rays, the frequency will increase, but the wavelength will decrease. So as we go from left to right, the frequency will increase, and as we go from left to right again, the wavelength will be decreased. So this goes up, the frequency goes up, and the lambda goes down. How can we see that in drawing? Look at this wave. And as we are in the radio waves have the greatest wavelength. الآن لاحظوا كيف طبعا بنميز wavelength, the distance between the peak and the peak, or the crest and the crest. This distance is the greatest in radio waves. As we go further towards the gamma ray, for example, لاحظوا الآن شو صارت بالdistance between the crests. It's much less than the one compared to the radio waves. طيب شو الفرق بيناتهم أيضا؟ في عنا الفريكونسي, the number of oscillations we have in 1 second. As we go towards the gamma ray, the frequency will increase. طب هل مطلوب مني فقط اللي هو موضوع ترتيب الالكترومagnetic سبيكترم فقط؟ لا، برضه مطلوب منا الفيزيبل لايت. لازم نعرف ترتيب الألوان بالفيزيبل لايت according to their frequency and wavelength. لأن طبعا ألوان القوس ظاهرة عندنا، ألوان قوس القزح اللي هي احنا بنسميها الفيزيبل لايت, the colors that we can see. And as we go from this point to this point, the color will be shifted. We start with red, then orange, then yellow, and then we have green, then comes the blue, then we have indigo or indigo, then we have the violet. So we can memorize that as Roy G. Bev, Roy G. Bev, where each let's say letter represents a different color. As we go from left to right, here the frequency will increase, but as we go again from left to right, the wavelength will be decreased, or it will go down. Now, different uses for the electromagnetic waves we should know of. For example, radio waves, they are used for broadcasting information. Microwaves, they are used in cellular phones, GPS, microwave ovens. Infrared, they are used in infrared cameras and night vision goggles. Heating buildings. طبعا احنا لازم نذكر انه الانفراريد دائما هي اللي بتحمل فعليا الحراره، اللي هو الهيت انرجي موجوده دائما عندنا بالانفراريد. And as we go from there, now these waves are harm to human beings اللي هم الالترا فايوليت الاكس راي والجاما ريز. لكن radio waves والمايكروويفز والانفراريد they are not harmful to humans. فبالتالي اول شيء مشترك ما بين الالترا فايوليت والاكس راي والجاما راي they are harmful. طب نيجي على الالترا فايوليت. They are used in ionizing molecules and atoms, causing chemical reactions, sterilizing instruments. X-rays are used in medical imaging and cancer treatment. Finally, gamma rays, they are also used in cancer treatment. لكن لازم يكون في عندنا تقييد شديد في موضوع استخدام الجاما ريز والاكس ريز because they are very dangerous. الآن نيجي على القانون المذكور في الهيكل. هذا القانون يستخدم لحساب سرعة اللي هو electromagnetic wave in the different mediums. الميديومز طبعا ممكن تكون عبارة عن glass، ممكن تكون water، ممكن air، ممكن diamonds and so on. As the type of medium change, also the what we call the dielectric constant will change. When عندي dielectric constant, this is called the dielectric constant. Then what is this? This is the dielectric constant. It is unitless and it depends on the the type of the medium that we are talking about. طيب what is n? n is the index of refraction. Since k is equal to square of n, that means also that v is equal to c over n. Directly. ليش؟ لأنه بما أنه الآن القانون c over the square root of k, if we take the square root for both sides, the square root of k is equal to n. But we can substitute in terms of اللي هو square root of k, we can put n. So again it becomes v equals c over n. Anyway, let's see how we can use this equation to solve the problems mentioned in the coverage. أولاً, if the speed of light traveling through water is 2.25 times 10 to the power 8 meters per second, what is the dielectric constant of water? What is the index of refraction of water? طيب, أولاً هو معطينا the speed. This is the speed as is of the water where the wave of light in water. So this is called v. كم السي؟ السي لازم نكون حافظينها اللي هي 3 times 10 to the power 8. طالب منا أولاً dielectric constant اللي هو اللي هو k, and then we need to find the index of refraction of water اللي هو n. How can we do that? We start with v equals c divided by the square root of k. Now we plug in the values we have, which is 2.25 times 10 to the power 8 equals 3 times 10 to the power 8 على square root of k. الآن in calculator we do not have to substitute the 10 to the power 8. ما في داعي نعوض بالكالكوليتر فقط، لكن على الورقة تكتب. فقط في هذا السؤال ما في داعي نكتب اللي هو times 10 to the power 8. ما في داعي. ليش؟ لأنه راح نكنسلها من الطرفين فعليا. يعني basically this will cancel this. So in the calculator we say 2.25 equals 3 divided by the square root of x. No, sorry. This is x. Again, alpha x. Okay. So shift calc equal بيعطينا مقدار ال k. It's 1.78. So k accordingly is 1.78. Now how to find the index of refraction اللي هو part 2. طالب من index of refraction هي عبارة عن n. To find the index of refraction we should know that n squared is equal to k. So basically n is equal to the square root of k. طيب, what is the value of n based on that? Now finding the square root of the answer will give us the solution. So it's equal to 1.33. It's equal to 1.33. And that is it for this question. ننتقل الآن إلى السؤال اللي بعده. يحكينا which of the following statements is true about electromagnetic waves? A. Electromagnetic waves are created due to vibrations between electric and magnetic fields that can propagate in matter only. This is incorrect. B. Electromagnetic waves are created due vibrations between electric and magnetic fields that can propagate in vacuum only. This is also incorrect. C طب شو الفرق؟ نفس الكلام لكن شو بيحكينا؟ They can propagate in matter and vacuum. So the correct answer is C. ننتقل إلى question 80. Electromagnetic waves have specific characteristics. Which among the following characteristics does not correspond to electromagnetic waves? A. They have wavelength. They also have a speed. They have frequency, but they do not have a mass. So this characteristic is not correspondent to electromagnetic waves. So the answer is D. Question 82. What is the correct relation among the wavelength, frequency, and the speed of propagation? نعرف القانون هو اللامدا is equal to V over F. We can also write it down as F equals V over lambda, or we can say that V is equal to lambda times F. Let's check the answers. أول واحدة lambda F على V. No, it should be V over F. So this is incorrect. B, V equals lambda times F. This is correct. C, V is lambda over F. This is incorrect. And finally D, V is F over lambda. This is also incorrect. So the correct answer is B. طيب ننتقل الآن إلى question 82. نقرأ السؤال الأول. What is the speed of an electromagnetic wave traveling through air? Use C to be 299,792,458 meters per second. So we have to use this number for C. Again, if we want to find the speed, we can use اللي هو V equals C over, and we can write down N, which is the index of refraction. Why? Because the index of refraction of air is equal to around 1.00027. And this, of course, you don't have to memorize that. It will be given in the exam, so don't worry about it. So if we want to find V, it's equal to the number of C, or the value of C, which is 299,792 or 58 divided by اللي هو الآن N, which is equal to 1.00027. And if we use the calculator for this, we get 299,792 or 58 divided by 1.00027. And the answer will be, again, it will be a very long number, which is around 2.99. We write it down. 2.9971 times 10 to the power 8. So it's equal to the 2.9971 times 10 to the power 8. And the unit is in meters per second. How did I know that this is 10 to the power 8? If we go to the calculator here and press on this again, let's do it again. Sorry, the answer. So this is times 10 to the power 6. If you shift this decimal again 2 digits to the left, راح يصير عندي هاي 10 to the power 8. So basically it's 29971 times 10 to the power 8. Anyway, let's go to question 43. بيحكي لنا الآن water has a dielectric constant of 1.77. What is the speed of light in water? طيب طالب لنا الآن speed of light in water. Again, we will use the same equation. معطيني dielectric constant اللي هو ال K. راح أكتب ال V equals C over the square root of K. راح نلتزم مقدار ال C اللي هو 3 times 10 to the power 8 لأنه ما أعطاني قيمة غيرها على اللي هو square root of 1.77 اللي هو إحنا فعليا هذا السؤال حليناه مسبقا. يعطينا ال V. Once we do shift solve بيطلع لنا ال V is equal to 2.25 times 10 to the power 8 meters per second. Question 44. The speed of light traveling through a material is 2.43 times 10 to the power 8. What is the dielectric constant of that material? Again, we say V equals C over the square root of K. Now this is 2.43 times 10 to the power 8 equals 3 times 10 to the power 8 على square root of K. You can use the calculator now to find this answer. So 2.43 times 10 to the power 8 3 times 1 times 10 to the power 8 على square root of x. طبعا الجواب around 1.52. إذن 1.2. Finally, question 45. A radio signal is transmitted from Earth's surface to the moon's surface. 290 kilometers away. What is the shortest time a reply can be expected? If we draw, for example, this is sketch to represent the Earth and the Moon. The distance between the surface of the Earth and the Moon is given as 376,290 kilometers. طيب هو طالب لنا الآن shortest time a reply can be expected، يعني going back and forth. وكونه حكى لنا shortest time معناته the wave will be transmitted or will be moving with the speed of light in vacuum اللي هو 3 times 10 to the power 8. كونه طالب منا الآن shortest time of reply, this is a back and forth travel or trip. So it will go to the moon, it will be reflected from the surface of the moon and go back to the surface of the Earth. So instead of using this distance once, we have to use it twice. يعني multiply this number by 2. طيب كيف نحسب التايم؟ احنا بنعرف قانون V is equal to distance over time, meaning that the time is equal to distance over the velocity. لكن which velocity? It's the speed of light in space, which is basically c. So instead of writing V, I will write down c. Based on that, let's find the time. Time is equal again 2 times 376,290. كونه طالب أعطانا بالكيلومترز, we have to multiply by 1000 to convert from kilometers to meters. Divided by the speed of light, over 3 times 10 to the power 8. And again, we can use the calculator to find this number. Then 2 times 376,290 times 1000 over 3 times 10 to the power 8. يطلع لنا الجواب around 2.51 seconds. إذن T. And that is the end of basically question 82. ننتقل الآن إلى الجزئية اللي بعدها. Question 83. في هذا السؤال بيحكي لنا at which region ultraviolet waves should be. لأن إذا نظرنا إلى ترتيب visible spectrum عفوا electromagnetic spectrum, إحنا الآن من اليسار بدينا في الجاما راي. طيب لأن we should know that what comes after the gamma ray is basically the X-ray, then the ultraviolet. So basically we should know that the ultraviolet has to be in the or region 2. So we choose 2. And this is basically the end of that part. Now let's go to اللي هو question 10 in the EOT coverage, which is basically the last part we have of lesson 3. Determine the optimal length or orientation of an antenna for the best reception of a given wave. الآن راح نتكلم شوي عن الانتناز and types of antennas before we dive into the questions. We have 4 types of antennas اللي هم long antennas, short antennas, hidden antennas and dish antennas. راح نركز على الأولى والثانية اللي هم long والshort antennas. الآن بالنسبة لللونج antennas, they are basically wire antennas that are one half the length of the electromagnetic wave. يعني as you can see here, for example, if we have a wavelength of 1 meter, this is lambda. Then the distance from the tip to the tip of the long antenna should be lambda over 2, يعني 1 over 2 meters, يعني half meter. طيب why is that? Because if we stick with that number, we have the highest possible potential difference across the terminals. Accordingly, we will have the most efficient type of antennas, which is the long antennas. And these are the most efficient. طيب الآن if we go to the short antennas, the distance from the tip to the tip is lambda over 4. Again, for instance, if lambda is equal to 1 meters, then here this distance will be equal to 0.25 meters. Now what is the difference? Here we have less amount of metal, فبالتالي the vibration of the potential difference across the terminals will be less, and accordingly it will be also less efficient compared to the long antennas. طبعا الهيدن والديش antennas يعني معلومات عامة لازم نعرف عنهم. It's good to read both. It's good to read those both. ننتقل الآن إلى question 84 كما ذكر في الهيكل. في هذا السؤال بيحكي لنا radio signals. Radio antennas normally have metal rod elements that are oriented horizontally. From this information, what can you deduce about the directions of the electric fields in radio signals? Now, if we go back to this drawing just to understand the concept, this is the wavefront of the electromagnetic wave. As you can see, since it's oriented in this direction, meaning that the electromagnetic wave has to be also horizontal. So if we go back to this question, بيحكي لنا radio antennas normally have metal rod elements that are oriented horizontally, meaning that the electromagnetic waves also has to be horizontal. So that means the electromagnetic waves have to be also horizontal. طبعا according to what? According to the drawing that we have just seen. طيب ننتقل الآن إلى question 85. Question 85 is basically a reflection for question 51 in the book. حكينا في هذا السؤال: Would an FM antenna designed to be most sensitive to stations near 88 megahertz be shorter or longer than one designed to receive stations near 108 megahertz? طيب الآن طبعا we have to explain our reasoning. الآن here we have two different frequencies. We have 88 megahertz and we have 108 megahertz. And we know that the greater the frequency is, the shorter the wavelength. فبالتالي this will have اللي هو longer wavelength, and this will have a shorter wavelength. طبعا why? Because if we keep C constants, we should know that lambda is inversely proportional to the frequency. If we increase the frequency, the wavelength will be decreased, and vice versa. According to that, which one will be shorter and which one will be longer? وطالب منا في هذا السؤال بحكي لنا: Would an FM antenna designed to be most sensitive to stations near 88 megahertz be shorter or longer than one designed to receive stations near 108 megahertz? Again, based on that, has to be longer. طبعا why? Because the greater, or let's say the smaller the frequency is, the longer the wavelength is. واحنا كما شفنا احنا طبعا بالنسبه للشورت انتنز واللونج انتنز، الديزاين للانتنه نفسه راح يكون اعتماده على شو؟ اعتماده على الطول الموجي. اما بيكون في عندي شورت انتنه او لونج انتنه. In both ways it depends on the wavelength. In long antennas it has to be lambda over 2, and in short antennas it has to be lambda over 4. In either way كل ما ازداد عندي الطول الموجي اللي هو اللامدا كل ما ازداد طول الانتنه. واحنا قارنا الان ال 88 ميجا هرتز بال 108 ميجا هرتز، واتفقنا بانه هاي القيمه اقل، فبالتالي راح يكون عندها اللونجر اللامدا اللي هو الويف لينث، فبالتالي accordingly this antenna has to be also longer. طيب ننتقل الى question 86. في هذا السؤال بحكي لنا the length of the wire antenna is significant for receiving clear signals. Which of the following choices is correct? A. Wire antennas that are 1/4 the length of the electromagnetic waves are the most efficient. B. Wire antennas that are 1/2 the length of the electromagnetic wavelength are less efficient. Wire antennas that are 1/2 the length of the electromagnetic wave have a less potential difference across their terminals. D. Wire antennas that are 1/4 the length of the electromagnetic wavelengths have a less potential difference across their terminals. طبعا answer D is correct. Why؟ قارنا احنا ال 1/4 اللي هو wavelength lambda over 4 واللامدا over 2. حكينا in case of the lambda over 2 this corresponds to long antennas and this one corresponds to short antennas. واتفقنا بأن short antennas they have less potential difference, meaning that they are less efficient. Whereas in the case of the long antennas اتفقنا بأنه الدلتا V across the terminals is greater. Accordingly, the efficiency is also greater compared to that one. هو بيحكينا عن 1/4 of the length of the electromagnetic wavelength have a less potential difference across their terminals. That is correct. طب if we go for example to C, wire antennas that are 1/2 the wavelength they have less potential difference. This is incorrect. What about B? Wire antennas that are 1/2 the wavelength or the length of the electromagnetic wavelength are less efficient. This is incorrect. They have greater efficiency. They are more efficient. So this is incorrect. And A, wire antennas that are 1/4 the length of the electromagnetic waves are the most efficient, and this is also incorrect. So the correct answer is D. And this is the end of اللي هو part 3 of the revision. إن شاء الله في الحصة القادمة اللي راح تكون عبارة عن آخر حصة لمراجعة الهيكل راح نتطرق إلى آخر درس موجود عندنا في الكتاب بإذن الله تعالى. السلام عليكم.